So we continue here again with the quadrant angle. So terminal side, angle, standard position, terminal side is going to be on an axis. So first example, just a ray, stays right here on the positive x-axis, 0 degrees or 0 radians. Ordered pair are 0. If we're right up here on the y-axis, again, going counterclockwise, 0r is your ordered pair, 90-degree angle, or in terms of radians, pi over 2. Full half circle, negative r is 0, 180 degrees, pi radians. And if we go here, 270 degrees, 3 pi over 2 radians, and our ordered pair would be 0, negative r. Now the final scenario would be getting a full circle, which then you'd see the difference. Full circle would come all the way around. We'd be back at R0, but we'd be at 360 degrees and then 2 pi radians. So the orientation. So again, the orientation is going to be important that we pay attention to that. So let's look at an example here. So the terminal side of theta, it's in standard position, contains a point 0.06. Find all 6 trig functions. Again, even though we're one of these angles now, it's still, we got to find x, y, and r. Well, with an ordered pair, you know x and y are given to you, so we have to do a little Pythagorean theorem, or think for it a little bit. As we work through this, 0 squared plus 6 squared equals 36 squared. So we got that all set up. So as we set up all of our trig functions, y over r, we get 1. X over r, we get 0, can be an answer. Tangent, we get an undefined trig function, so that can happen. Cosecant, back to 1, but now secant becomes the undefined because 6 over 0, and then cotangent becomes 0, 0 over 6. So again, it's practice with these, finding our different pieces so we can get them mastered. Alright, now let's talk reference angle here, shall we? So, reference angle theta prime. This is going to be now theta prime different than theta. It's going to be the acute angle formed by the terminal side and the x-axis. These two things are important. Terminal side, so our reference angle theta, again, is made by terminal side and the x-axis. So now we're going to start working about, other than the special right triangles and anything on the axis. So here in quadrant 1, it's simply going to be whatever theta is. Here's your x-axis. So there's your angle all the way up to 90 degrees. In quadrant 2, where most people would consider an obtuse angle, we've got theta, but again, by definition, it's the terminal side and the x-axis. So theta prime is going to be this small angle here, the acute angle. So x-axis. So two ways of doing it. We've got to remember our thadians. We've got to remember our radians. And theta prime will be 180 minus theta. Many of you will just crank that out in your head. The radians, remember, this is pi. So then it's pi minus theta. And we'll write it in terms of pi. When we get into quadrant 3, now, again, we're all the way here, but again, it's the x-axis and the terminal side that make the angles. So here's theta prime. So theta prime will be theta minus 180, because now it's past 180 degrees. It's going to give us the acute angle that we want, the positive acute angle. And then in radians, that'll be theta minus pi. And finally, here in quadrant 4, we've got the big angle going. For those of you that are old school, kind of looks like Pac-Man right now. Theta prime will now be made from the positive x-axis and our terminal side here. So now it's 360 minus theta gives us the acute angle, or in terms of radians, 2 pi minus theta. So our four scenarios